Hello everyone, I'm Xiaogang. Okay, now let's write the code here. Then we'll first create a third-person template. Let's open our ebook launcher. I'll just go ahead and create it directly. Then we'll name it Light Demo. Mainly, when we make this multiplayer game, we'll write some C++ code. Okay, after we finish creating it, we'll duplicate the player's start point. Why duplicate it? Because it's better to have multiple ones. If they all spawn at the same location, there might be collisions. When there are collisions, it can cause the player to fail to spawn. That would cause the second and third players to, then it won't have this character. This will cause some problems. So why pull out 2 here? We can use 2 modes to check here. Okay, so this proves that up to this step, we are normal. And the document says, actually, all normal actors need to be replicated. Obviously, our character has a component that supports movement replication, so we can just ignore it. Regarding the movement component part, because Unreal Engine should have recently provided the latest, this movement component may be revised. What does this mean? Not enough creator to launch or pro. The meaning of this is actually because we click into this editor. This should be a newly added feature in 5.4. Sometimes, to make it easier for you to simulate, it will let you provide this. We'll just write something casual, just write this thing, because it might make it easier for you to simulate. It will provide information like a key. We just wrote it casually. Differentiate this name. Don't make the names the same. At this point, we start it again. Then after we finish executing, it won't have this problem anymore. Right? You see, now there's no talk of warnings. Right, okay. Then how does this player move? I don't need to teach everyone that. This thing, like us, it is through the animation blueprint. In the animation blueprint, we can see, if we look at this blueprint, it should be here. It should be here. We find his mesh. It is him. After finding him, we are here. This actually only swapped one model. So we just look at this one. Okay, it retrieves it right here. Some information on this character. Of course, this node might sometimes fail to get this actor. For some reason, this node sometimes fails at this point because it might fail due to timing issues. It will fail. There is a movement component here. After finding the movement component, get the velocity of the movement component or some directional acceleration values to set them into the animation blueprints. Once you have these variables, you can go into the anim graph and simply create a state machine. These animations and this 1D blend space are all quite simple. So I won't go into detail. Then we'll start writing our C++ code. Over here, everyone should be familiar with because we use it often. But maybe we are currently doing it in phases, writing these things out properly. But in reality, these things, that is to say, step by step, you will gradually combine many things together. Maybe we are only writing a synchronous one now. Later you will have many inventory components, skill components. We will cover this in later cases, because if we combine them all at the beginning, it will cause problems when learning each chapter. And then, this is generally adding a few attributes. First we add a default attribute like this. For this default attribute, it refers to a maximum health value. It does not need to be replicated over the network. Then we need to add a current health value. This current health value does need network replication, and the red color here means, this red metadata indicates that when this value changes, it will trigger this method. Then here we write a method like this in this place. Once we have this method, we need to create an implementation for it. And you will find that this implementation is actually incorrect. It is not written this way. Oh no, that's wrong. This one is correct. It is written like this. What I was just trying to say is, it has some functions. It needs to add this implication. Some relatively special functions need to be added. Okay, if this compilation passes, it proves there's no problem. Then in this part, here are some long. We've already covered this. Covered it many times in Decay. And now, here, we should go ahead and perform a simple initialization of this value, because for this initialization, we are actually hard-coding it in the constructor function right now, and then this value actually can be modified later. For example, this value can be changed during the editing phase. And generally in the game, we might read from a table because different health values may vary. Next, we will include this method. As for this method, let's write it here. This is a method of property replication. Because currently there is a variable here, it needs property replication. So it's better to separate it like this, move it up here. Personally, I like to put variables below. Inside here, put this part here. Okay, let's implement this method. Well, for this method, first, it definitely needs to call the parent class method, and the creation position here doesn't seem right. Let's move it. Okay, the reason it's not quite right is because its own position is written incorrectly. As for this method, it should actually be written above. So let's just ignore it. It's because this one itself, you see, these two methods are in reverse positions. Let's ignore it. Okay? We need to adjust the parent class's method here, because if you don't call the parent class, you'll miss something. Okay, then at this point, we inject the current health value into it. Okay. Now it's reporting this error, right? Let's write it like this. And it currently doesn't have this red. So what do we need to do? We need to include this header file. Okay, let's go to the very top. Let's put this at the very bottom. Okay, after including it conditionally like this. This property has been successfully registered. Our compilation should be fine now. It keeps prompting me to save here. Okay, let's wait patiently. Okay, compilation is fine here. Now let's take a look at this method. Where does it come from? It comes from having this in its parent class method. You will find that in this place, it synchronizes a lot of information. You can see, look, we can see this red one is directly synchronized, and this one has conditional synchronization. As for these synchronizations, you can see by clicking into it. This place states so many rules. Everyone can click in and take a look. We won't read it out verbatim because it's not very meaningful. Then we mainly look at its parent class. Then, let's take another look. Look, this is fat, right? Let's take another look, okay? Then you can see this is an actor. Look, there are none of these things. Then here we don't have a super. We bring it into the header file. You'll see that this comment says that this is used to handle some properties for network synchronization. It processes them, and this part needs to be overridden. That is, for the actor class. If you want to add a new property, this method is right here, okay? Now let's go back to our Carter. You know this method, just know what it does. Here we only. For our custom part, we only need to do this. Just replicate the current health value. Then next, we need to prepare a method to update the health value. Okay, so this method, we place it here, mainly to respond to changes in health. So we have such a method. Then when the health value changes, what do we need to do? Obviously, this function, it is invoked on both the server and the client. So first of all, we will set the call location. It must be manually called on the server. Then on the client, it is called via the network. Property callback method. Let's just write this part first. Then, when writing this method, we need to distinguish between server and client. First of all, we will write the client side functionality first. On the client side, it is this character. This character must have netbook replication enabled. According to his method, this is a method in Punk. Let's check the slide mode if it is on the client side. Then we print a log because it lost health. Then we prepare an F stream through printful. It tells you how much health you have left. Because after you modify this, we can directly read its member variable. Then we print this health value. Of course, at this point, we usually play the collection animation. At this point, we usually play the collection animation. Then after we deduct the health, whether he is currently in a situation where this is less than 0, if it is less than 0, then we log a message saying that you have died. This is done on the client side. Usually, a death animation is played here, and player control is removed, among other functions. Then next, on the server, what do we need to do? Actually, on the server side, It's the same for us. We also need to check his remaining health, so we prepare this health value. Just check the current, how much health you have left. But it is done on the server. Then we use the server. We print it out in blue like this. After completing it like this, then you might need some damage statistics here. That is, who dealt damage to you. And then you need to do something similar to damage statistics or things like threat determination. Then at this point, you can write it in this position. If it needs to be done on both the server and the client, then write it like this. And following the idea of connecting the preceding and the following. Actually, this is our later idea. So how do we trigger this series of operations? When we trigger it, we first need to prepare some methods. Let's explain these methods one by one, what they are used for. First, here, because this variable is political, it might be used elsewhere. So here we provide an entry function to access it. Then we can get the maximum health. We can also get the current health value. This stands forced here because it is a very short pure function. Forced here point can help us speed up programming. Some things, it's a piece of C++ knowledge. Then, if you force a class point, usually it's a ternary operator, or just return a value. Don't do it inside the forced class. No, reverse. This way, there will be some problems because writing that is useless anyway. Okay, then here we prepare a function. This function means when we modify the health value, we all call it through this function because we want an entry function to call it. Okay, let's first create this entry function. Okay, after creating it, we'll leave it alone. Then we also need to prepare a method. That is a method for receiving damage. Let's paste the method over first. You can follow along with me. I think we'll paste and explain at the same time. No rush. Okay, so this method is an override method. It is a TakeDamage method. Let's override it. Then you'll notice it has these parameters here, right? So these few parameters are actually the method it has prepared. This should be a method inherited from actors. Yes, right. And as for this method, we can look at it one by one. Before we continue writing code, first, on the character side, it probably doesn't have it because it hasn't overridden this method. It should also now be in pump. Let's check. You can see it is in pump. So in this place, there will be a should take damage. Then we usually drop the negative class here, the method of the negative class. Then after the negative position drops, return this calculated damage value. Then this parent class method must be inside the actor. We can see inside the actor. We find inside the actor. Okay. We can see where it is. Here you can see this place. This document might not be clickable. It should not be clickable because our UE5 has to go through the documentation once. There is actually documentation here. Oh my god. Although it is in English, right? So let's first take a look. I'll show you. It should be fine. That is to say, this place applies a damage. When applying to this actor, we will receive damage. So this is the incoming damage, and then it's a damage event. Then the injective here and cursor are equivalent to who is responsible for this damage and who actually caused the damage. So this concept is actually a very interesting concept. How to describe it? Well, actually, it's about us causing damage. Actually, we are all managed by the controller. That is, we are the players. We deal damage. Or when we deal damage, for example, our bullets, our knives, spears, clubs, rocket launchers, and grenades. Well, this is actually the COSA. This is ingested. Okay, that's roughly what this function means. And as long as you override this function, later, by using another method to apply damaging, you can trigger a callback. Then we can take a quick look at this document. This document has some broken links. We'll right-click and translate it into Chinese. I wonder if any of you have seen it. So that's the game concept of damage from last time. And here there is a damage type. That is, it may have multiple types. So, fire damage. This event is how we define a damage type. We can define damage with various attributes. And the instigator is the person who causes the damage. And the causer is who caused this damage. So this is in the C++ code. Then you just need to override this method. Right. And this is a damage event type. In UE5, that is point damage and radial damage, and this is a common general damage model. Okay, you can take a look if you're interested. We will use this point damage later. You use this function, it can receive tech damage. It's a really great thing, because before we had gas, when we were making games, we had to define our own damage system. or just use the engines. Of course, we would use the engines. Okay, so this document is briefly covered here. Then let's come back to this place, back to our character. So next, we will prepare these two methods. We need to complete these two methods. Right, then here, we use setCons. With setCons, actually, we mainly just modify the health value. Here we need to do a judgment of the upper and lower limits of this value. Obviously, we only allow it to be used on the server. If it is on the client, we simply do nothing at all. If it's on the client, it means there is a problem with your code. Yes, then in this place, we give it, share the remaining of this. This health value has been limited. After the limitation is completed, we update this. We first update it on the server, then the client. It will connect through the network because the value you modified, it is replicated. So it is replicated, such a value. Then it will connect through the network to trigger this function. Trigger this OnRep. No, it triggers this OnRep. It triggers this function on the client through the network. Then it will also come in. So this is what it means here. Then let's take a look at TakeDamage. How should we write it? For TakeDamage, we can simply do a subtraction here. After the subtraction, that's our current health value. Then we can set it to the current value here. Okay, set the current value. We return this value. And there's one point here, whether we should allow negative values or not. That depends on your design, because you are calculating damage. Maybe this aider's damage calculation logic is different, although they all have this function. You can say this TakeDamage. We just don't call it parent class. That's it. We will write a new set of logic ourselves, because if you call the parent class's calculation result might be different, because we can clearly see this TakeDamage. At this pump level, it actually has some logic written in it. Has some logic written right here. Let's calc it. Okay, it actually adds some damage determination here. That is whether it can accept damage, because you might need it for some pairs. It is invincible, right? That's right. Some judgments, that is, it's not on the server, or there's no permission, or some of this can be damage. After turning it off, it might still be invincible. So if you also want to use this logic, you can use it. Your super here, and some logic is also written in super, you can see. So we'll leave it alone here. Okay, we'll just let it directly accept this damage. When we continue to emphasize, we'll emphasize this process again, because we are now layering up and down. Actually, we are only going down now. When our character deals damage, it will come from the TakeDamage point. It is an overridden method. Then after you deal damage to it, its TakeDamage receives the damage. When receiving damage, how does it deal damage to him? There are some cost damage functions like apply damage. Then our character will take damage. After it receives the damage, it will modify the health value. On the server side, it directly updates the health value, while the client will receive a network event. Each client through the network event, because this is a network variable. Then the network event will trigger this function. Then each client updates the health value on its own. And within the health value update, we will, based on this, here, corresponding work will be done based on the competition judgment at both ends. Okay, let's stop here for now.